Okay, moving right along on this amazing day. Our next speaker is Young from Ambassador Labs, a developer advocate, a role very near and dear to my heart, of course. Young is going to be talking about cloud native, zero trust, multiple projects, one goal. Sounds very community oriented. I can't wait to hear it. Hi, Young. How are you doing?
Hi, I'm good. How are you?
Doing very well. I think we met at All Things Open last year. It's so lovely to
Yes,
see you
yes.
again.
Same here.
Awesome. Good, good. Well, we're gonna
We're
duck
gonna.
out and let you take it away.
All right, cool, awesome. 1 second. All right. Hello, everyone. Welcome to my talk on Cloud Native Zero Trust, multiple projects, one goal. My name is Edidio Ngasipo. It can often be hard for people who are not from Nigeria to pronounce. So if you can't pronounce Edidio, then you can just call me Didi. I currently work as a senior developer advocate at Ambassador Labs, and you'd oftentimes find me writing, building, or sharing knowledge with people in the tech community. I go by Didi Codes on all my social media platforms except LinkedIn, which I go by like my first name and last name. So if you ever want to connect on social media, then just search for Didi Codes or Edidio Ngasipo, and you'll be sure to find me on one of them. All right, let's get right into it. So traditionally, the tech industry has relied on the perimeter security model, which makes it hard to obtain access from outside the network, but assumes that everyone inside the network should be given access to all of the resources without asking any questions. And this security model only focuses on who goes into and outside of the network and not necessarily what they do when they're inside that network. One of the drawbacks of the security model is that if, let's assume, an attacker, for instance, happens to gain access into the network, because the security model does not necessarily check what's going on and is only concerned with who gets in or who leaves, it means that the attacker would have access to do or cause lots of havoc on the system. And aside from this, right, the perimeter security model worked for some time. I mean, there was a point in the world where we didn't really need to be focused or worried about certain things. But the truth is that the world is currently changing. And because the world is changing, technology also has to adapt to how the world has changed. So for instance, companies no longer have their data in one place, and certain information is often spread across cloud vendors. And then we also now have thousands of individuals connecting from home computers outside of an IT department's control. So this means that following the assumption that a user who has access to a network is automatically good doesn't cut it anymore and could lead to like data breaches that could cost millions of dollars. We've all bumped into a couple of articles on Twitter or whatever social media platform you're on about data breaches happening to some of the most secure tech companies in the world. So it's something that if you don't take the necessary precautions, can happen to your company as well. So in order for us to adapt to the world, we need to take our security another step further. And this is where zero trust comes in. So the zero trust model was created to address the security challenges of the perimeter security model. And according to zero trust, even within a security perimeter established by a network or a firewall, you must treat all users, systems, and network traffic as fundamentally untrusted. So zero trust requires that we rework the way we think about identity, and more specifically, system identity. And that instead of assuming that every single person who has access to a network is automatically good, you should always think of them as, oh, hey, this is a breach about to happen, and then go further to verify each request as if they were coming from an open network. So when the perimeter security model says trust anyone and anything inside the network, zero trust says never trust and always verify. It encourages you to always ensure that every single request is fully authenticated, authorized, and encrypted before granting access to the user or the person who wants to access the network. There are so many benefits of utilizing zero trust. I included 3 because I wanted us to just like point out the very key ones, and also because this talk is like a 15-minute talk where I'll go straight into the point. So the first thing is that it empowers your users to work securely anywhere, anytime, and on any device. It also enables digital transformation with intelligent security for today's complex environment. Like I mentioned earlier, the world is changing. People are working from home. There's like so many things that are happening now that didn't happen like 4 or 5 years ago. So a security model like this helps you to adapt to the current level of things happening in the world. And then finally, it helps to close security gaps and minimize risks of lateral movement. Due to the many benefits of zero trust, it has increasingly become popular in the cloud-native ecosystem and in other industries across the world. If you're in the cloud-native ecosystem, you've probably been hearing things like zero trust and the service mesh, zero trust and certificate management, and even zero trust and policy enforcement. And because of these benefits, several cloud-native companies have tried to incorporate the zero trust security model into their open source tools. For instance, here are like some open source projects that address zero trust in one way or the other. Emissary-ingress runs at the edge of the cluster, providing secure access to the cluster with TLS and enforcing end-user authentication. Linkerd, on the other hand, manages secure communication inside the cluster, supporting mutual TLS everywhere, and enforcing low-level security policies. Then we have Sets Manager, just like the name implies, which manages the many TLS certificates you need to ensure that identity within and outside of a cluster is correct. Then we have Polaris, which keeps an eye on exactly which policies are defined and ensures that nobody is straying away from those cloud-native best practices that you've set up for the application. And yes, all of these different open source tools address different aspects of zero trust, right? But then it's also possible for all of these tools to work together to create a system that is secured in all of the different bits. So one of the things we're doing at KubeCrash today is to show you how these different open source projects can work together instead of necessarily talking about them in isolation. So let me show you a quick demo architecture of how we've combined these different open source projects and what it turns out or what it makes the application to be at the end. So we have a cluster, this circle here, just think of it as a cluster. And then outside of that cluster, we have a single page web app, which serves as the graphical user interface, which most people call GUI of the application. So this GUI here talks to the service called face inside the cluster. And then the first service then talks to the smiley service and also the color service. So the smiley service would always return a smiling emoji or a smile, while the color service would always return the color green. The first service then combines these two services together and then passes it on to the graphical user interface. So the GUI then gets all of these services and it kind of does it in like different cells, meaning that each cell is going to be calling the first service to give it the smiley service and the color service together. So with the first open source project we're using here is Emissary-ingress. We're using that as our ingress controller. So it means that the GUI is talking to Emissary-ingress and Emissary-ingress is then talking to the face service. Then we have Linkerd, which mediates all of the information happening inside the cluster. So Linkerd is this small lobster icon you're seeing here. And then we have the Sets Manager. So the Sets Manager gets the certificate that Emissary-ingress uses to identify itself to the browser. And then it's also responsible for all of the certificates that is used for mutual TLS when working with workload identity on Linkerd. We have another tool, Polaris. And then what Polaris does is it runs in the cluster and it keeps an eye on what is going on inside the cluster. And it's doing this to ensure that every single cloud-native best practices or every single thing that we've shared in regards to zero trust is being followed. Because sometimes people might end up doing things without realizing that it goes against this zero trust best practices. So you use Polaris to try to manage that. And if anytime something goes wrong or is not going as planned, Polaris would alert you on that. So with all of these different open source projects, we've been able to combine them to build out an application that is secured. And then what this does is that it creates an application that runs in an environment where every access is checked every time and at every level of the infrastructure. So I'm going to quickly open up the application now. So I'm going to click on this Faces app and open the link. I may have to stop sharing my slides for a second and reshare again so you'd see it on your end. 1 second. Cheers. All right, so I believe everyone can see the Faces application now. All right, cool. So this is the demo that I just showed you in the architecture. I showed you the architectural aspect of how the demo was created. So this is what it looks like on the web. So as you can see here, this is the GUI that has those face service that I talked about. The first service calls the smiley service and the color service, and then prints out these different emojis on our screen. And you can see here that we've integrated all of these different open source projects to ensure that this application is completely secured and addresses different things. Linkerd, which addresses what's happening inside the cluster in terms of communication, and then Sets Manager, which addresses the different certificates, and Polaris, which ensures that you are maintaining all of the different best practices that were set in regards to zero trust. And of course, Emissary-ingress, which serves as the ingress controller, and it's communicating between the external traffic coming in and the application itself. So I'm going back to my slide. 1 second, just resharing again. All right, awesome. So on going back to my slides, in conclusion, you'd see that the world is evolving, right? So we need a security model that would enable us to embrace the rapid hybrid workspace, which I talked about. So many of us are now working from home, gone are those days where everybody had to go into the office. So you need to ensure that even though someone has access to a certain network, they are still secured, or you're still ensuring or checking that this person is doing the right thing, unlike the perimeter security model, which would assume that as long as I have access to the network, then it means that I can do anything, access any resource, and all of that. So the zero trust security model embraces the hybrid workspace, protects people, devices, applications, and data wherever they are located. And most importantly, it effectively adapts to the complexity of the modern environment, which of course continues to change. And the zero trust model is ensuring that, hey, I don't trust anybody, and I would always confirm that this person or this device is actually meant to be here, even though they have access to the network. So in summary, what we talked about today, like I mentioned, this is just a quick intro talk before we go into deeper versions or deeper details on how zero trust works with other open source projects. So in summary, we talked about the perimeter security approach and how it typically used to focus on who was getting into the network and who was leaving, but not necessarily on what they were doing inside the network, because it assumed that everybody who had access to the network was automatically good. So if you're good enough to get in, then it means that, okay, everything is great, go ahead and do whatever you want to do. And then we talked about the zero trust, like what zero trust is and why it needs to be adopted, because it addresses some of these challenges that the perimeter security model did not address. I shared several open source projects like Emissary-ingress, Linkerd, Sets Manager, and Polaris, who all target different versions or different ideologies of zero trust. And then finally, I showed you how all of these open source projects can work hand in hand to build or help you create an application that is fully secured and in every single point, like from outside, internally, to ensure that you're following the best practice and all of that. But that's not all that's going to happen today. After I'm done with this talk, we're going to have several other people talk about zero trust. We have Dave, who will be talking about securing the front door, configuring TLS in Emissary-ingress with Sets Manager. Alex will be speaking on the well-tampered mesh, Linkerd, zero trust, and the application. And then Tim will be talking on generating and distributing trusted certificates using Sets Manager and Trust Manager. Then finally, Stevie will talk about zero trust policy enforcement with Polaris. All of these people are several experts working in these open source projects, and they are going to highlight how these different open source projects help to get you secured using zero trust. But they won't just focus on the specific open source projects, but they will show you how they can work hand in hand with other projects. Thank you very much. Do stay tuned for all of those talks. And like I mentioned, if you want to follow me on social media, you can check me out at DD Codes.